Okay, so last hour for today, we were talking about sequences, and I said now we are going to talk about FASTA file and GenBank files. Any questions so far? Any comments? So before we start dealing with more interesting things, there are FASTA and the GenBank. There are two files, or maybe more, stored in some public place. One is in FASTA format, and the other one is in GenBank format. If I click on this link, I just kept it in the slides, and then if I move the top window of Zoom so I can click on these things. So this is how it looks like, okay? This is the FASTA format, okay? One file about the orchid, I guess, with some metadata here, and then the sequence. And then more of these, I don't know, you understand that there's a letter C here, and there's no letter C here. That's basically what I can see as difference. For you, it probably have more meaning. Okay, so that's one of them. And the other one is the GenBank file, which probably contains the same exact sequences, but with it seems that way more metadata it has, okay, in fields and so. Okay, so now we can download this, and you could, okay, you could just open the file. I mean, you could download the file from here, and then open the file and start parsing it with using, we haven't learned regular expressions. I'm not sure if it will, but you can extract, you can read them line by line, find if the word, I don't know, locus is there, I don't know what is locus here, or keywords is there, and then find what are the keywords, and then you can say origin, find the origin, and then the lines after it, that's the sequence. You could do that, of course, but there's no point for it because there's a library that can read it and then provide you access to various parts of this this file. And we'll take a look at this in a bit, but before we do that, I wanted to show you why is that more interesting. So you probably are familiar with this database, the National Center for Biotechnology Information, NCBI. Okay, I go there, and specifically it has, as much as I understand, it's basically a few huge databases, and you can search for here something from nucleotide, let's say orchid, okay, whatever. I have no idea what I was just looking for. Search, okay, and then let me enlarge this so you can see it on the screen as well. And then here we can find something. It got 24 hits for the search. And then here you can actually go and download the GenBank or FASTA files. Exactly like the formats we have there. Those are just examples. So here we could, that's even better. So I just got some pop-up here, and I have to say no thanks in this survey. Why is it better for me now that I got this? Because what I wanted to tell you is that what you really would like probably is not to get some sample data, but to search on this website, then download the, let's say, GenBank files because they have more information, and then use many of these GenBank files you want to download, and then use that data to do some kind of analysis. So what can you do? You can come here, search for whatever you need, find it, okay, or think that that's relevant. Click on the GenBank link. Okay, let me click here. Okay, what happens? Now I can see this data here, and I don't think that I remember how to download it. I think this one. No, this is just jumping the sequences. Send to. Coding sequence, GenBank file, choose destination, file, create file. Lovely. Okay, sequence GB I just got. Let me check this one. Downloads. Sequence DB. Yes, this is exactly what we had an example, right? So this is in GeneBank format. So far, I'll keep it there for now. Maybe we'll use it. So now this did some manual, it got involved, we did some manual work in order to download, to find whatever we needed and to download it. And the question is going to be, okay, how can I write a program to do all this? Okay, how can I write a program that can, and the first thing would be, oh, do the same thing as I did. Okay, and there are various techniques that allow you to implement something that acts just as a regular user on a website. The big issue is with this approach of writing a program that will come here to this website, fill out the form, click on the button, scroll down, click on the GeneBank, notice that there is the pop-up. Well, so that's where the first problem is, that the program needed to notice that pop-up that I noticed, because I am sort of a human. Okay, I can even check the checkbox of the CAPTCHA. The CAPTCHA, you know, that the thing that they ask if you're a human. If the computer wants you to prove that you are a human. Okay, these are called CAPTCHA, when you have to find the bicycles or the whatever traffic lights. Now they don't have it here, but that we had that pop-up, and I had to use my human intelligence to understand which button to click in order to continue. If you write a program and suddenly they introduce this banner, this pop-up banner, your program will stop working, because the program doesn't know what to do with it. A human can handle this, albeit maybe the human will complain that why do they have this pop-up now, but the human can get over this. The program can't. Okay, it will just stop, and then you will have to rewrite your program, improve whatever, change, and it can happen. Remember, we had this COVID. So during COVID, they had a banner here up at the top telling something about, I don't know, keep a distance from your DNA sequence or whatever. I don't know. Okay. What does it mean? That if I wrote a program that knew that the third link from the left is the link that I can click on, now is the fourth, because they included the text with a link. Okay, so my program started to break. Not good. Okay, but this is one way to handle the problem, and this is very fragile. The other way is that there is something what we call the API, or Application Programming Interface, and some websites provide this API, and this is what I wanted to show you with the where I know that there is an API. I don't know about this website. Where is the API? I wanted to show the API here with the Open Weathermap. So let me show that. Slight sidestepping here. So this is another website that provides you with weather data. Okay, it can provide you weather forecast, historical weather data, whatever. And for something, even maybe for your research, you might need this weather data, whether to see if you can do the experiment now or should postpone it for next week, whatever. You can look at the website, search for city and so on, but you can also go and click on the API and then read all the documentation. You probably need to sign up to this website. Then you can get an API key. Okay, they keep wanting me to sign up, but I'm already logged in, so I'm not sure what's the story, whatever. And then I can write a program that uses this API to interact with just the data. So basically what you have is behind all these things, there is a database. And what you can see here is, what we can see here, the web page is designed for human consumption. It has nice colors. it changes the colors, I don't know, in winter or night mode and day mode and whatever. Okay, they move around things as they think that it might be better for us, and we usually complain about it, but whatever. But for programs, it's much better that everything is always fixed. And they don't care about the colors. They only care about the name of the field and the value. And that's where APIs are. Basically, you can send a request, and you receive back usually something, a JSON format. The one that we discussed, right? That we can read with the JSON library. And depending on the system, okay, so you can talk to this API and get all kind of data. And you probably, if this is some popular website, like this Open Weathermap, you probably don't even have to implement all the communication with the website, because let's see if it's true for the Open API, Open Weathermap. So Open Weathermap, yep, it has quite a few libraries implemented. This is rather old, this is newer. I don't know what does do each one of them. There are newer, Open Weather API. Okay, so there are several of these libraries, just like the OpenPyXL, right? We use the OpenPyXL. Now these are libraries to interact with the website. So someone has already created you a library, Python library, where you can just call functions. You give the function the specific keywords that you are looking for. Sorry, the phone rings here. Someone else will answer here at home. Okay, it stopped. Good. Someone already implemented these functions, so you don't really need to know that much about the API. You just use the functions. Okay, you just have to find the right module and so on. What you probably need on this, on this website, you definitely need an API key. So they want to identify each person who's sending the request. So I had to register, and I can come here, and I think if I click on sign up, you already signed in, okay, whatever. And I can here, there are the API keys, and I can click, if I click, okay, it took a little few seconds. It created API key. I can create API, generate API keys. I'm going to remove this one because these are not in use anymore, and they are on the video anyway, so they shouldn't be public, because these are private actions. Whatever, okay. Doesn't matter. So these are the API keys, and you can use the API keys to interact with the website. If I go back to the main page, you can also see, no, I need to go to the API page, that you get 1,000 API calls per day for free. And beyond that, you have to pay some actually minor amount of money. Okay, this is how the Open Weathermap works. That they provide the data, you can get 1,000 requests per day, free of charge. For the rest, you have to pay. And in order to manage all this, you have to have these keys, okay, the API keys. That's fine. Any questions about this? Okay. When you feel ready, just ask a question. If I go back to the NCBI website, website, they work slightly differently. They sort of trust people, okay? So they don't ask you to register in order to use some API key. they don't charge you money, but on the other hand, they don't give you the weather, okay, and neither the results of the expected values of the lotto, okay. They give you sequences. So whatever, they give you trust, okay, fine. How can we use it? We will see it later. The only thing they ask you is to provide your email address, and actually you could lie, okay. So they ask you to provide your email address, basically, so if they notice that there is a program that sends in way too many requests that they can't handle, then they can send a polite or not so polite email to please stop, okay, or mention you. I mean, their assumption is that the people won't abuse their system, but there might be mistakes in your program, in our program, that creates a loop that generates lots of requests, and they will want you to let you know that please don't do that, okay. And so that's a good reason to provide your own email address for that, okay. And we'll see that. And this, what will this allow me? It will allow me to actually search the database and download the GenBank files programmatically. So I can write a program and will do all the work that you saw I did earlier manually here, okay? And that can be quite useful. So let me get back to the first step, basically, or maybe it's not the first step, but this is what we can do. So here you have the URLs of these FASTA file and the GenBank files. And in this program that you can access through the slides, there are two functions here, basically. One of them is programmatically downloading the file from the address, which are linked here also, but they are also embedded in the code. So they are downloading, that's one function. And the other function is reading the content of the file and printing out some data. Now, we don't need both of them actually now because I've already manually downloaded, but let me go through them. So the get file would get this address. We also call it URL or universal resource I think link, I'm not sure, but this is the name, the URL. This is the address of what we have here, okay? And we are using a library called requests. This is the Python library that can download pages basically from the internet, okay? Because that's it. This is a page on the internet. It becomes a file downloaded, but it's a page on the internet. And so we can say request get, and we give it the URL, this address. We got back some result, and this result have a status code, and the status code would be not 200 if the request was successful. And what we say here, that is, if it's not 200, then just, you may remember we were talking about an exceptions. Now we are raising an exception. Just say out, okay, I'm done. I can't do anything anymore. Okay. And then somewhere and at the top, you might be able to handle this. Basically, stop the program, complain. Okay. But if this is not different from 200, so basically meaning that the request was successful and we have the data, then we are opening a file name, which we got here from the call of the function. We're opening a file for writing. We haven't seen this earlier, I think, but this is how you open a file for writing. And again, we get back this file handler, and then we can write into the file. So earlier we saw how to read from a file. This is very similar. We just, when we open, we tell it explicitly that we would like to write to the file, and then we write to the file the result.txt. So this result.txt, that's the content of what we received from the website. Okay, so this is how this program could download, and then this is how I call it. I get file and then provided this URL in this variable and the name of the file, which I called ls or origin, which is basically the same as we have here. I just wanted to explicitly give the name here. It's also, yeah, so this is the get file. And you can see that I do the same here with the other one. I'm calling the get file function with the other address and the other file name. And then for each one of them in this example, I call the process file function, which gets the name of the local file, okay, that was already downloaded, and the type of the file. Now, I could deduct the type of the file from the extension fasta and GBK, but for some reason I didn't want to deal with that in this case. So instead of that, I had the type of the file, created a variable, and put the type of the file here as a string. Fasta, or in the other case, it's called GeneBank. This is the type of the file, the internal format of the file, right? So basically, how to understand this. So how does this process file function work? It doesn't do much again. It uses the sequen.io class that we saw a little bit in this example here. Actually, it's not the same. Well, it's not the same, but sorry. Okay, this is not the same, but sort of the behind the scenes similar idea. Okay, so there is the sequen.io library from Bio that has a parse function, and what it gets the name of a file on your disk and the type of the file, whether a GeneBank or fasta, or I don't know, whatever format it can handle. Actually, let's see it. So seq.io biopython. Let's search for this. Parse. Okay. So here you can see the parse. I don't know if there is an explanation. Okay, it can handle Plustal format as well. I have no idea what that is. Okay. Way more information that I would like to read now. And here you have examples with that. Okay, but that's okay. Let me enlarge the font again. But that's what you will have to do a lot. That you find these libraries, whatever you use, in this case, the biopython library, and try to figure out how to use it to do these things. Okay, so here we saw, so we haven't finished it. So there's a seq.io parse. It gets the name of the file and the type of the file. And what it returns is something that we can iterate over it. We saw this, that we saw already several times that we can write for something, a variable, in something else, and then it would iterate over those things. We saw this when we were iterating over the characters of a string. We saw it when we were iterating over the elements in a list, the lines of a file. So you can iterate over you can iterate over all kinds of things in Python. In general, the generic term for the things that you can iterate over them is iterable, because you can iterate over them. Okay, so these are iterables. So what we would say here, that this seq.io parse returns an iterable. That's how I guess it's, even if I go to the documentation of it, if I didn't close it, yeah, parse read documentation maybe. Okay, we are just here. Oh, it doesn't say iterable. Maybe it says, but it says, and returns a sec record iterator. Okay, it uses the word iterator. Okay, fine. But you can see also here the example that it says for record. They call them records each. I mean, you remember, right? In this one, we had one and then another one and another one. So we have several sequences in a file. Each one is called a record. And in the record, there are fields. So that's what we do. We iterate over the sequence record, we called it here. And then it has all kinds of fields, an ID, the sequence itself. We can print the whole thing somehow. Oh, no, sorry. I print out the length of it. Okay, you can access various information. I mean, that GeneBank file had a lot of information, so you can access them here. Right. Any comments, questions? Let's copy this one. Let me copy it. CP, work, slides, Python examples, science, read faster. Okay, Python, read faster. Okay, that's it. If I run git status, sorry, we can't see it because, so you can see here are the two files that it just downloaded. I can remove them again, ls something. I just remove these two files. And I run the program again, so you can see it. That's it. Now I run ls again, and the files are back because we downloaded and saved them here. Okay, so the program downloaded. Okay, so that's it. We just saw this working, and it printed out stuff. Let me open it. Read faster. Read faster. Let's see what happens here. Sequence record dot. It doesn't like me. Strange. What's the problem? I don't know why it doesn't offer me the list of functions. I was hoping for. Actually, I can do something here. Oh, I can show you this thingy. Print dir. And I'm going to comment out these ones. Okay, I don't want to see. Actually, I can just call break here. Okay. And there's no semicolon. So basically, okay, and I comment out. So it won't complain. So basically what I said, okay, start going over the records, print out the dir of the record. I'll see it in a second, and then break out from the loop. Okay, so it's printed out twice, okay, because once for each of the files. These are the attributes / methods of that object. So you can see that there is the ID. Okay, let me print it out once. Okay, instead of that, I call it just exit. And then it will print out once and done. So we don't have the duplicate. Let me enlarge a little bit. Okay, larger letters. You see all kind of these underscore methods or attributes. They are mostly they are internal for Python. We don't care about them for now. Fine. There are a few of these single underscore. They are internal to the object that we are dealing with. We don't care too much about them for now. One day, maybe The most important ones are the ones that start here, right? That don't start with an underscore, so annotations. I have no idea what it is. It's probably some meta information from the file, data file, and then count, and we use the ID, right? So we had this in this code, we use the ID and the sequence part. But there's also the name. Okay, let's put the name here. So let's show the name. Name. And we don't need this one. Name is 6. No, oh, sorry. I was printing down the length of the name. Lovely. Okay. Beautiful names, right? Beautiful names. I have no idea what is this. Okay? You'll have to figure it out. That's some biology thing. But this is, so this dir statement, basically, if you have an object in Python, you can call dir, and it will list you all of its attributes and all of its methods. And then you can learn from it. For some reason, the editor doesn't show it. It should, okay? And that's basically that's not what the editor shows, the listing from the dir. I don't know why it doesn't know. Okay, fine. I won't argue with it too much now. Okay, probably you can also read the documentation somewhere, and then it will help. Okay, so let's go with this one now. Search nucleotides. I'm going to copy that one as well. Okay, so what do we have here? From the bio library, we are importing a class, basically, which is called Entrez. Let me comment this out for now. We provide somehow a term. So this term is the thing that you, as a human, would type in here. Okay? That's the search term. And here I just created a variable, and this is just a string. Okay? Whatever you can type there, you can provide here. Then we call the Entrez eSearch. We tell it that we are using the nucleotide database. I think here, this is the selector. Okay? There are many other databases here, but we were using the nucleotide because that's what I managed to understand a little bit. Okay? So we tell it what kind of database. How to call the others? Find the documentation. It should be there. Then we provide the field term, and we put the variable term. This one, so just to make sure, this variable is placed here. This is the name of the field. I could rename this to term X, and then I have to, of course, rename here term X. Okay? And then, but this is the same, it's term. I leave it here. ID type, okay? Again, I'm not really familiar what does this say. There, I think when you return here, you can get back various types of IDs, okay? And this tells the system which ID to return, okay, fine. And another thing is that what if I search for orchid, okay? So the previous one returned 24 hits. This one returns a little bit more, okay, 500,000 hits, but it shows you the first 20 of them. And then you can click on next, or you can type in the page. It's called paging, that you have several pages, many pages of the data. So that's how the website works. As I write the code, I can tell it how many to retrieve. Like in the previous search, we got 24. So if I say retmax, retmax 30, it will still return just 24 because that's what we have. But now that we have 500,000, it will return the first 30. And I'm quite sure that you can also provide a page number here, or somehow tell it, okay, give me the next page, okay, the next 30, or the next, I don't know, 100. You have to research it a little bit, how to get more data of it. Okay, so we can call this Entrez e-search. This does the search, and this sort of gives you returning a list of what are these sequences or organisms, each hit here, I don't know, entries in the database. Okay, so we get this handle, and then we can use the Entrez read to read the handle into a record, and then we can ask from the record how many we have total. Okay, so this search term returned a total of 538, but because we asked for 30 only, in the ID list, we only get 30 IDs, and well, that I know it because I just checked with the len function. Okay, so this is how you can retrieve some data from that specific database, and then you should call the close method on this handle, so it will not hang around, whatever. You could have used we could have used the with statement, just as we use it with the open. And here's another one, the orchid that I showed you. It has 500,000. Once when I wrote this code, the result was 530,000. Now it's 546,000. What else? Let's run this. Search nucleotides. So as you can, so first of all, here are the results printed out. Okay, the count, the ID list count, it's the ID list, 31, it's total, or the what retrieved now. But we get a nasty warning here. Email address is not specified. Okay, and that's because I commented it out. Okay, so I provide the email address, and now without a warning. Okay, so they are sort of saying, okay, we will work even if you don't provide the email address, but better to provide. And it's better to provide your real one, because then we can reach you if you really need to. Okay, so now we have the search results, but we still only have the IDs. We don't have the sequences yet. So this is the next example. In this example, we are using again this Entrez, and this, I don't know if I need this. No, I don't actually need the sequence, I think. So let's go over. Here too, I provide the email address. I have the document ID. So one of the IDs basically that we returned earlier. And in this program, I just put it here. And then we call the eFetch method. So previously we had the eSearch. Now we use the eFetch method. Again, we provide the name of the database, nucleotide, the ID. We tell it what type to download, whether it's FASTA or GeneBank and so on. And well, here we need to use GB in order to say gene bank. In the previous one, we had to use the word gene bank. It's not the same everywhere. Okay, we just have to accept that people like to make up their own mind and decide how to call something or how to shorten the gene bank, the word gene bank. And I don't know what is this ret mode, but I'm fine with this. So this returns a handle. I can call read on this handle, and this returns the data. Now I can close the handle. And that's it. The data contains, in text format, whatever is in that text file. And then again, we just save it. So let's copy this one. Fetch nucleotide. And I even comment out the second part, because this is only reading the file again back and printing out stuff. Python fetch nucleotide. So now it knows what is the ID, and it downloaded the, what's it called? Temp data. Okay, a brilliant name, I know. It's called temp data. Let's see how it looks like. Temp data. It looks like a gene bank file, okay, that we saw earlier. And then now you can continue using writing some other program that will analyze it. And so let me allow this one. Okay, so this is the sequence annotation. This whole thing. So you can see there are all kind of key value pairs. This is basically a dictionary, right? Key value, key value, key value, and then you can deal with it. We already know how to deal with dictionary. Any questions? I see. I have some exercises here, so I will figure out which one what to give you as an assignment. But basically, that's it. Any questions before we go today? Any questions about the project? Anyone would like to discuss ideas?
Can I talk to you when we finish the lecture, like privately?
Yeah, fine.
Thank you.
Anyone else? Just who was this? Was this Mazal? Excuse me, who wanted to talk to me?
Yeah, it was me, Mazal. Yeah.
Okay. Okay, I just didn't see the. Okay, so let's stop the recording and finish, and then other people can leave. And actually, what we should do, we should finish the. No, then I can't use it anymore. Okay, so let's stop the recording, and then we can talk. Okay. And that's it.